In this video we are going to discuss the basic rules of differentiation. We call it part 2. If we have the function f of x plus g of x, and we take the derivative of the two functions, of the sum of the two functions, we have the derivative of the first function plus the derivative of the second function. Using the Leibniz notation, we can write it like this, with a d dx. I can split the derivative with respect to x of the first function plus the derivative with respect to g with respect to x of the second function, number 1. If we have the difference of two functions, f of x minus g of x, derivative equals the derivative of the first function minus the derivative of the second function. Using the Leibniz notation, f of x minus g of x is the derivative of f minus the derivative of g. Rule number 3. When I have the derivative f of f times g of the product of two functions, I can write it as the derivative of the first function times the second function plus the first function times the derivative of the second function. d dx f of x times g of x equals df over dx times g of x plus f of x dg over dx. Number 4. If I have the quotient f of x over g of x and I want to compute the derivative, I take the derivative of the first function times the derivative of the times the second function, which is in the denominator, minus f of x g prime of x over g squared of x. When I have the quotient of two functions, I can write the numerator, the derivative times the function in the denominator minus f of x g prime of x over g squared. Chain rule. If I have the function f of g of x, a function inside another function prime, I can write f prime g of x times g prime of x. Or you can see this as df g of x over dx. You can write it as d f g of x over d g of x times d g of x over dx. Okay, let's see. We have the sum, the difference, the product of the two functions, the quotient, and the composition of two functions. Let's have a look at some examples. You have f of x equals x squared plus e to the power of x. F prime of x equals the derivative of x squared plus the derivative of the exponential. 2x, the derivative of x squared plus e to the power of x. Another example, g of x equals sine x plus cos x plus x. G prime of x equals the derivative of the first function plus the derivative of the second function plus the derivative of the third function. Cos x minus sine x plus 1. The derivative of sine x is cos x. The derivative of cos x is minus sin x. The derivative of x is equal to 1. Example, m of x equals e to the power of x ln x. M prime of x equals the derivative of first function times ln x plus e to the power of x ln x derivative. The derivative of e to the power of x is e to the power of x ln x plus e to the power of x times 1 over x. Q of x equals x over e to the power of x. Q prime of x equals x prime e to the power of x minus x e to the power of x prime over e to the power of x squared. The derivative of x is 1, so we write e to the power of x minus the derivative of the exponential is the exponential, and we write x e to the power of x, and the denominator is e to the power of 2x. P of x equals e to the minus brackets x squared plus x plus 1. P prime of x equals the derivative of I want to compute the derivative of this function. So the derivative of the exponential is the exponential, so I rewrite this part, times the derivative here, the derivative in the power minus x squared plus x plus 1 derivative. The derivative of this one is minus 2x plus 1 times e to the minus x squared plus x plus 1. It's a composite function. Let me do another example. F of x equals ln e to the power of x plus x plus 1. So I take the derivative. What is the derivative of the natural logarithm? Is 1 over e to the x plus 1 times e to the x plus 1 prime. The derivative of this is e to the power of x plus 1 over e to the power of x plus 1. These are the basic rules when you try to differentiate sum of functions, difference, product of two functions, quotient of two functions, or composite functions. And this is the part 2 of our differentiation of functions series.